Hi. Today we'll discuss about biological to artificial neurons. See, let me go through this PPT and I will explain you in detail. Biological neurons. So what is meant by biological neuron? So you know that the information transmits from one neuron to other neuron. So that is nothing but it gets the information or it receives the information from several neurons and it will transmit that information to other neuron or set of neurons. That is nothing but the building block. So if you see in artificial intelligence, we have to convert all these biological neurons into artificial neurons. Neuron means here neuron is nothing but a particular node. In neurons, in biological neurons, there are dendrites. Dendrite is nothing but the receiver end. So at receiver end, it receives so much information, whether it's audio information or the image information, whatever it may be. So once the information has been received, then what it does? Immediately it stores that entire information in a particular memory. In the same manner, if you convert this biological neuron to artificial neuron, then what you have to do? Here you have to maintain the same concept like receive some information and produce output. In biological neurons, what happens? Suppose if you view a particular object, let's consider an apple. If you by seeing that apple, you can immediately recognize that that particular object belongs to apple. See, how can you recognize that particular object belongs to apple or not? Because previously you might have seen that particular object and that information has been stored in your memory. Whenever you get that information as input, then immediately in the brain it checks whether that particular object has been stored in the database. Means in the artificial intelligence we call it as database. Here in biological neural networks we call it as memory. So if in memory, if that particular object has been matched, then immediately it will identify that that particular object is apple. So for that one, to convert the similar type of information from biological to artificial, here you have to maintain so many neurons. Neurons means here neurons are nothing but the nodes. Means the entire information will be stored in the form of matrix. Matrix means one grid. So one each and every particular position or particular cell is considered as one neuron. Here we pass this information as input. Once the information has been inputted, then what happens? Then immediately it will process that information and finally it gives the output. As I mentioned, in biological neural network, the information was already stored. Suppose if you have seen one new object that is not apple, that color, property, odor and taste, everything looks different. Then immediately you might ask question, what is this? Because that information was not stored in your memory. If information was already stored, then if you see that particular object again, then immediately from the memory it will pick up that information. If that matches with the memory, then it will give you the output. Means you will identify that particular object whether apple or not. In the same manner, in biological neural network, you have to pass information as input and at the same time you need to store the output information in a particular database. Here we are passing input as information and at the same time we have stored hundreds of images and hundreds of audio clippings and hundreds of thousands of information in a particular database. So whenever we process one input information, means we are sending information to a particular neuron. That neuron is nothing but the artificial neuron. Once the information has been received, then immediately it will process that information. To process that information, so many things will happen between input and at the receiver end. So we'll discuss in later chapters how the information gets processed from input to output. So right now the basic concept of sending information from input to output is, first it receives the information, then it will process that particular information. Once the information has been processed, then immediately at each and every step it will cross check whether the particular information has been matched with the existing output which was already stored in the database. If information has been matched, then it will then it will process that information, then you will get the desired output. If you see this one, see, artificial neurons mimicking biological counterparts. As I mentioned here, if we want to maintain biological neurons, means first you need to understand how artificial neurons works, right? If you want create new artificial neuron, then you need to understand how biological neuron works, right? In biological neuron, in the previous example, I have shown you this one is cell body and it contains dendrites. Each cell body contains hundreds or millions or thousands of dendrites, right? So these dendrites receives the information and it passes that information to other cell body. Other cell body is nothing but other neuron. So before sending this information from one cell body to another cell body, again the brain will identify whether the information should be passed from one neuron to other neuron or set of other neurons, and from there again to other neuron or set of other neurons. This entire decision will be taken within a fraction of second. So you have to correlate this information and you have to implement the same type of concept in biological neural network also. See, design and architecture of artificial neurons. So as I mentioned, so before designing and before creating the architecture for artificial neurons, first you need to understand how the data gets transmitted in biological neurons. These are the top 6 advantages of artificial intelligence. Means these are not only the advantages of AI, but there are so many advantages by using artificial intelligence, but at high level there are 6 advantages. First one is reducing errors. So how to reduce errors? Means by using human brain we can able to achieve some goals, but we suppose if we want to do some robotic surgery, suppose if a human person or human doctor is operating a particular brain, means it contains hundreds or thousands of nanoneurons, right? While cutting that particular nanoneuron, instead of cutting one neuron, suppose if he cuts another neuron, the entire body gets paralyzed. So you have to reduce the errors. By using artificial intelligence, by using the robotic surgery, instead of touching another neuron, it will sharply cut only that particular neuron and it operates successfully. So that's why this is one example how to reduce errors. There are such type of so many applications wherein we can reduce errors. The second one is digital assistance. Digital assistance means in nowadays in our day-to-day life, so we are using digital assistants not only in Google search. Even if you take Google Assistant, it will assist you by using the digital assistant only. It will prompt you. Suppose if you want to ask some question, so by typing the question, it understands what type of question you are going to ask in the next time. So immediately it will prompt you it will predict you the type of questions you are going to ask, and it will give you the hint. So that is nothing but the digital hint. And increased productivity. Increased productivity means by using artificial intelligence we can increase the productivity. Means suppose if you take any agriculture sector or medical sector, okay, previously we were dependent on the human efforts. Now by taking the artificial intelligence, it intelligently takes the decisions, and instead of wasting the time, instead of spending lot of time, what type of disease a particular patient is suffering, so instead of that, just by scanning his entire body, it gives the suggestion, and it will also gives the information like what type of cells, what type of pus cells are existing in his body, whether they are benign cells or cancerous cells. So this type of information will be provided without wasting much time. So that's why the productivity gets increased. Next, transform medical sector. So this is very huge development in the medical sector. So if you take brain scanning means it's very too complex. It takes hundreds of pictures on the brain, right? After taking hundreds of pictures, then it processes each image and it identifies whether the brain has any tumors or not. Suppose if any small tumor is there, then immediately it analyzes, artificial intelligence analyzes by processing each and every image whether the tumor, what type of tumor it is, whether it has any pus cells as I mentioned, whether it has any cancerous cells, and what type of what type of medication you need to provide, whether the surgery is required or something else, whether the radiotherapy is required. So the entire information will be provided by medical sector by using this artificial intelligence. And managing redundant tasks. Managing redundant tasks means instead of working on the same set of instructions, so it will intelligently decide whether you need to carry out all those redundant steps or not. Suppose if they are not required, only one step is required instead of multiple steps only, but that particular step will be carried out and the remaining steps will be ignored. And the availability is very flexible. So next one is challenges in creating artificial neurons. Challenges means, as I mentioned, brain is most complicated machine. So to understand brain itself takes a lot of time, and it's too difficult to implement exactly from biological neurons to artificial neurons. Only thing is, though we got very good results in some areas, still it is in research and development mode, because still human is not in a position to understand completely how the brain has been designed. The thing is that, see, suppose if you observe some old persons, if you ask some question, immediately they don't answer. They can't recognize you also. The reason behind that is that, as I mentioned, in biological neural network, we have to give input, and at the same time you have to store the entire information in the database. So every time continuously it checks whether the input and the output already stored in the database are matching or not. If it matches with the, if the input is getting matched with the output already stored in the database, then immediately it gives the desired output. So in human brain, what happens? Suppose if a old person is not in a position to recognize a particular person, then what we'll do? We'll give hints like this person belongs to that person's father, or that father's son is this person, and this guy has married to that girl, and you also attended this his marriage. Like that, we have to give some input parameters. In the same manner, in the biological neural network also, you have to train the system. Train the system means you have to give input parameters as much as you can, and at the same time you have to store the output information as much as you can in the database. Then only, without losing any information, you will get the desired outputs. Okay, applications of artificial neurons means we have already discussed about this one. Artificial neurons play a crucial role in machine learning and deep neural networks. So if you take any machine learning language or deep learning, so here there are so many algorithms like ReLU algorithm and AlexNet and GoogleNet. There are so many types of algorithms we'll discuss later. So by using those algorithms, those are very complex algorithms and most efficient algorithms. So by using those algorithms, within a short span of time, you can pass millions of parameters to process the information, and you can get the desired output. Instead of pausing, so during initial days of artificial intelligence, the applications were using only hundreds of parameters. Now, by using Alex neural network, there we can pass 60 million parameters. Just imagine 60 million parameters we can pass as input information. So that's why you can get the accurate result, and you don't see whether is there any difference between human brain and artificial brain. So by using this type of applications, we can able to do robotic surgery, and you can work on the space, and we can work on geographical conditions and so many things. Future developments means, see, still there is R&D is going on, so we don't know what type of future developments we'll get. But the thing is that they are using the biohybrid systems. Biohybrid systems means they are combining both biological neurons and artificial neurons to enhance the functionality. Right now, what happened, just we are replicating the biological neural network by understanding the sorry, we are replicating the artificial neural network just by understanding the biological neural network. But nowadays they are combining both artificial neurons and biological neurons to understand the brain functionality more effectively. Okay, these are ethical considerations. Ethical considerations means we can discuss in the later chapter, like what are the ethics you need to be followed while developing this artificial neurons, because while developing this artificial neurons, your personal information should not be disclosed, and you have to follow and you should not impact socially, economically, or even if you take the country safety or person safety, you should not impact. So you have to follow all these ethical considerations, and you have to implement this artificial intelligence. Thank you.